Okay, what we're going to do today is look at two different types of injectors. The peak and hold slash modulated injector, standard, or sometimes they call it the saturated injector. Same thing. We're going to look at the different signals they produce, and how the PCM controls them. Let's do this. Alright, what we're looking at here is called the pulse width modulated injector. Okay, this is a pulse width modulated injector. You can see the ECU slash PCM. This is system voltage here. This is where the PCM pulls at the ground. Now inside this injector, there's actually two different drivers. Okay, this first initial drive here is to get it open quickly. This takes about 1 millisecond. Alright, and it can pull up to 4 amps. Once it approaches about 4 amps, it switches to the second driver, which is this one here. This pulse width modulating section. You see this here? This was controlling the current down to about 1 amp. So about here, we get it open quickly with 4 amps. It lasts about 1 millisecond though. Then it switches drivers to control the amperage down to 1 amp. By pulse modulating it. This is this piece right here, this section right here. At this point here, this is where the injectors turn off, and we come back to system voltage again. The total pulse width of this injector is from here to here. If you actually accelerate this engine, you'll see this section move. This one won't move. This end moves. The second driver moves, increases and decreases. Now, you got the same two injectors. The top one, pulse is modulated, but under it, the current going through each injector, which is pretty cool to look at. As you can see, it's being turned on here. It's the same thing as this one. It's being pulled down, turned on. This is where it starts spraying fuel. The same thing here. In my system voltage, the PCM is pulling the ground to open up the injectors. This is the amperage is pulling here. You see the current, how much it's pulling? I think it's about 4 amps. Yeah, it's about I think it's about 4 amps. I'm not sure. I don't see it on here. But you can see right here, it's pulling the current. How high this is? Now, look at the difference here. I'll pull, turn it on. It's first driver. Once it gets about 4 amps, it lasts about 1 millisecond. It switches to the second driver. And this one brings it down to about 1 amp to control the current. You can see here, the same thing. You can see the current increase after the switch to drivers. You can see it drop. You can see how it's being pulse modulated here. You can see the ripples here also. The same thing over here. Here's a close-up look at this. Now look at this. This is pretty cool to look at. Now it's wrong. It's about 2.5 amps. See right here? This is the voltage reading, the red one. You see it being pulled down. This is being turned on. Now at the same time it's being turned on, like we learned back in the ignition coil section, we're looking for the current to ramp, as you see here. See how it's ramping? So after PCM turns it on, my current starts to flow. At this point here, this is just system voltage, no current. The circuit's off, no current. As soon as we turn it on, as soon as the PCM turns it on, my current starts to flow through the coil windings to open up the injector. Now look at this. As it starts to ramp, it coincides with this. See here? This one switches over. It peaks here about 2.5 amps. Then it switches to the second driver, as you see here. Which see, this lasts about 1 millisecond. Then it switches, which take the current from about this says 2.5 amps down to about 1 amp. Yeah, a little over 1 amp. You can see right here, it switches to the second driver. And this is what you see right here. This is what we were talking about earlier. This here. See this switch point here? This is what I was saying about here. Now you can see as it being pulse modulated, you can see that also the current oscillating. Now when it turns the injector, when the PCM turns the injector off, my pulse is from here at this point to the last peak. I always say from the first drop to the last spike. Right? And you can see the current goes to 0 again because you come back down to system voltage, that's when the injector is off. So my pulse width again is here, turn on point to the turn off point, the last spike. If I'm looking at the current, my pulse width would be here to here. I'll put a cursor here at this point here and this point here to get my pulse width. Now this is actually the wiring diagram for two throttle body injections. Now look at this. Here's the fuse. This fuse is feeding this injector. It splices over to this injector. It also goes over to the PCM. Now, if I'm going to check the current on this injector, usually you can check the current on the positive side or the negative side. But if I want to check the current on this injector, I'll probably want to put it on the positive side because I've been reading both injectors. Unless you want to read both injectors. If I want to check individual injectors, I will go to the driver side, the control side. This one right here for injector A. And this is injector B. Never put the clamp around both wires. Only one wire at a time. So if I put either one, one wire at a time, what I mean by that is, one wire at a time is, I want to put the low amperage probe across both these wires. I will put over this wire or this wire, never both at the same time. It will cancel out. Alright, so here, let's say I will put the wire, the low amp probe on this injector wire, or this injector wire for this one, to see the current in it. I can also put my voltmeter leads here or here to see the voltage signal. Right here, see the voltage signal, I can put on that same driver. To see this signal, I have to go to the driver's side. I have to be on this side. Okay, to see this signal, to see this signal here, my voltage signal, and see the pulses modulating like this, I would have to be on the control side. The amp probe, which is this one, the bottom one, it could go either side, here or here. But keep in mind, if I'm on the positive side, I'm looking at both injectors. I probably would just put it over this side here to see this injector, then to see this injector individually. Now this is a peak and hold injector. You see the difference from this one? No modulation here. So this is a peak and hold injector. System voltage and peak and hold and the pulse width modulating injectors are usually found on throttle body injections. Here's my system voltage here. I'm pulling it to ground. First driver, turn it off. Just to get it open quickly. Turn it off. It's going to ramp up real fast. Then switch to the second driver. So this is a peak and hold injector, not the modulated type. As you can see here, look at this. Injector 1, injector 2, you can see how it peaked. The first driver to get it open. Then once you switch to the second driver, you can see the current went through a resistor. And the current now being controlled. Somewhere around 1 amp. The first initial kick is a little under 4 amps. That's to get it open. Now once you switch it to the second driver, to control the current, is a little bit under 1 amp. You can really see it here. It's a really good picture. Look at this picture, it's really good. I turned it on and watch it ramp. Okay, see it? Once it turns off, remember this is the point when it turns off, the first driver turns off, then it switches over to the second driver, you can see the current changes here. Yeah, see right here, it's about 1 amp. Once it's on the second driver, to get it open quickly, is close to 4 amps. And again, this is about 1 millisecond. That's just to get it open quickly. It's going to ramp really fast. Then it's going to switch over to the second driver. And now I'm controlling the current. Now the current is being lowered to about 1 amp. This is a very good picture. And what you're looking at, I should have said earlier, is this ramping here. How much current the injector is actually pulling. And if I want to look at the voltage side of it, I'm looking at the spikes, right? These spikes could tell me I have a shorter injector. High current could tell me I have a shorter injector. Now you can see here, this is a different vehicle. You can see here I have 4 individual injectors. I got injector driver 4 and 3. Here, 4. It's injector drivers. Injector drivers 1 and 2. 1 and 2. But you can see the fuse, the voltage is coming from here, this relay. Okay. This is my fuel pump relay. Once it engages and pulls this up, it's going to also feed all 4 here, 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 and here injectors. Now I could put a clamp around here, but I'm seeing all 4 injectors at the same time. If I want to see individual injectors, I would have to go to their driver. Okay, over here, like I said, over here. Hold on. Alright, like I was saying is, if I want to see individual injectors, I would go to each individual driver. These, either one of these, or either one of these. This fuel pump relay, it feeds all 4. It feeds all 4 injectors at the same time. Now you can see it here. It's the current. Again, it's a current being pulled. You can see here the voltage. These 2 are the same injectors. Okay, the same picture. And over here, you can see the current for 2 more injectors. It's only 4 channels. The other one, the 4th one is left out. But you can see the current here and here. You see how it spikes, then it switches transistors to control the current. Pretty cool picture. Now we're going to talk about the standard or saturated injectors. You usually see this on multi-port sequential injection, multi-port injection, port injection. Now look at this. This is a great picture. Look at this. My saturated injector. See, no pulses modulating at all, or peak and hold. I have my system voltage, turns it on, pull it to the ground, hold it open to spray fuel. Turns it off, back down system voltage again. And here, lines right up. You can see, as my PCM turns the injector on, as I said earlier, you can see it starts to pull current, right, until it peaks out. Then when it turns off, I'm back down to system voltage again. System voltage, no current. You can see how it lines right up. Look at this. As soon as it turns off, my current goes down to 0. As soon as it turns on here, my current starts to climb. Pretty cool. Now, the thing you probably see, I want you to see this. That's my pulse width. Okay, that's the injector pulse width. From this point here to this turn off point here, it's the injector pulse width. That's probably like 6 milliseconds. It's 18 milliseconds time base over here. And I got 9 divisions. I'm starting 0 from here, so I'm counting 9 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided 18, 2 times. That's 2 milliseconds per division. So my pulse width here is 2, 4, 6. About 6 milliseconds. Now, my next one, look at this. I'm going to switch the cursors. It's going to switch. From here, I know you've seen this indication here and this indication here. This is actually the injector pintle moving. Here, on the opening side, on an amp probe it's showing when it's opening. On a voltage it's showing when it's closing. So this is my mechanical measurement of the injectors from opening to closing. Okay? Now here's the thing. I want you to understand something here. I'm seeing my injector being activated by the PCM. I see my injector pintle moving as it's been activated by the PCM. But understand this. This does not mean it's spraying fuel. This is just a mechanical and electrical picture of it. Okay, I've seen it electrically being open. I've seen the pintle mechanically moving here and here. But it does not necessarily mean it's spraying the fuel. I still can have a plug nozzle. Okay, and fuel may not come out. The only way I can check fuel volume is a pulse tester and see how much volume is coming out per injector. So keep that in mind. Just because you see a good signal does not mean it's spraying the fuel. This is just telling me electrically I have a good signal to this injector, but it does not tell me I'm spraying the fuel. So keep that in mind. Here is bank injection. You can see here I got a fuse here and a fuse here, and it's feeding this bank, and this one, number 13, is feeding this bank. On the other side, you can see that the ECM is controlling here for this bank, for this one bank, and on this bank you can see it's controlling here. So all 1, 2, 3, 4. So all 4 injectors on this bank sprays at once. All 4 on this bank sprays at once. And I want to check if I want to check the current on these injectors. I can put the low amp probe on this end, or this wire. Same thing here, either on this pink and black wire here or this wire here. But keep in mind, when they bank like this, the expected current might be higher because you're checking all 4 at the same time. A standard saturated injector with the amp probe next to it. Alright. This is all 4. Okay, I'm looking at this wiring diagram right here. If I'm checking this circuit here for voltage, I'm on the trigger wire. Here or here. Or here or here. I will see that. If I want to check the current, I could be either end, this end or this end. You can see here, system voltage, pull my current. As it turns on, my current starts to climb. But keep in mind, you're seeing all 4 injectors. Okay, you're seeing all 4 of these. I like when it turns off, you can see the current fall down to 0. Now, I hope this helps you understand how the injector is being controlled by the PCM and what the electrical signal looks like. If you have any further questions, please let me know. Peace, I'm out.